Cool. Okay, so today we have another lecture, uh, obviously, because today is a lecture day. And I want to start with Blitz. Very simple questions, very simple answers, just yes or no. I believe we will do everything correct. So, quick answers, okay? Do you like Python? Okay. Do you like Fast API?
Yeah.
Do you like using ChatGPT? Why? Do you like using any tools that use AI to generate content or to provide some kind of assistance?
Yeah.
Do you like to use ChatGPT to generate code for assignments for this course?
Oh,
Okay. I had to try. Okay. But the truth is, I also like using ChatGPT very much, and I also like using Python very much. So, and we thought actually that it will be really cool to show you how to create those systems that use AI as assistant to create some content and to provide this assistance. So, our lecture is called Building AI-Powered Backends with Python and LLMs. And actually, that's about LangChain. And I know that you should know something about LangChain.
yes.
Yeah. Okay, that's actually cool. Because maybe you already use it, maybe you know something, maybe you know how it works. That's okay. But I will try to explain you maybe more deeply, maybe show something that you haven't touched yet. So, yeah, let's start. So, LangChain. Obviously, it's something about Lang. What is Lang? It's language, obviously. And more specifically, it's about LLMs, large language models. I think all of you should know already what are LLMs. It's like things that generate, that can understand text and generate text, such things as ChatGPTs, Claude, Gemini models, and so on. And they work they process text as tokens, minimum units as words, actually not specifically words, maybe just fragments of words, generate text by predicting the next token, and those models are like stochastic, so the model doesn't always produce the same output, and you actually can control it. So I think like every model has this temperature, a parameter that you can control randomness. So the higher this parameter, the more creative the model is. And I think the most famous models are ones from OpenAI that are called GPTs. And OpenAI actually has an API that you can use to make those requests to OpenAI and to receive a response. And you can do it actually from your backends, from your API. So it's not like a client asking your server to receive information. It's like client asking your server, and then your server asking another API to receive information. So now your server is a client, but it's still a server for the clients, for the browser. Yeah, so actually I have an example of how it works, and I just need to find the correct, yeah, that's the one. So as you can see here, I have like, okay. I just need somehow to move it. Okay. So here you can see this simple route that I created in my Fast API. So let's just run it and try to zoom in. Can you remind me? Command plus.
Control.
Okay. Okay. I don't think. Okay. Okay. Is it better?
Yeah.
Cool. So let's actually run it. And we run it, and let's actually reload and see the documentation. I think here we also have to. Okay. So we have this our endpoint. Let's ask some question. Try it out. I just want to show that this is helpful assistant, and it's telling jokes. So tell me a joke about Python. So let's take a look how funny this joke. Why do Python programmers prefer dark mode? Because light attracts bugs. Okay, it's pretty good, I think.
Out of 10, maybe 6.
Okay, that's pretty good for GPT, actually. Okay, so yeah, that's just an example of how you can directly ask OpenAI to actually GPT model to receive some response. So how it works? First things first, you need OpenAI API key. Actually, this is, I think, horrible way to add your credentials into your program, because you actually don't want to hard code it in your application, in your code, because it can be easily stolen, and you don't want to commit it somewhere. Actually, later we will show you much better example how to add credentials. But for now, it's okay. It's okay. But in general, it's a horrible way, to be honest. We will fix that later. And actually, I will tell you later that for these practical assignments, we will have some restrictions. Now it's like totally mandatory to have your repository private, because in other case, these credentials can be stolen like immediately. And yeah, we have some restrictions. We will have some punishment if it will be public. So be very attentive. Yeah. So how it works? We just create an OpenAI client. We import it. We have this package called OpenAI. We import and create a client. It's automatically have this OpenAI key because it's an environment. And yeah, so we just specify the model, specify the temperature that I mentioned before, and we write a prompt. I for some reason have this wording, but never mind, it just works. So that's totally fine. So yeah, we have this small prompt where we have several roles like system, message, that just some instructions for your model. So you're a helpful assistant, you tell jokes. And the second message is from user, is actually our input from our API. And yeah, that's actually everything you need. It's very simple and it works. So yeah, that's actually how you can use OpenAI API. Okay, I have really a lot of different desktops. Okay, so if everything is so easy with OpenAI, why we need LangChain at all? Why we just cannot continue using OpenAI API? So actually, OpenAI API is just a simple tool, and LangChain is a framework. And framework is actually different frameworks in different, like, for different purposes are created to make your life easier, to make it more structured, to add some functionality from the box, and to make your life easier. And LangChain is not an exception. I think I would like you to think about it as, remember during previous assignments, you created this simple WSGI server where you have everything very in a ground level, everything in a single method, like routing, handling, returning response, parsing, and so on. And then compare it with Fast API, where everything is structured, where there's a lot of tools under the hood. And yeah, it's way more easier and faster to create. So the same thing actually about LangChain. So actually what LangChain provide for us, like structured workflows, so it's clear, it's reusable logic instead of like direct API calls, built-in components, it already has modules for prompts, memory, parsers, tools, and agents, cleaner integration. It has actually a lot of integrations with its, like different services, different databases, like really a lot. Scalable and observable via Langsmith, and I will show you later what is Langsmith. It's a very cool tool if you haven't seen it yet on different course. Have you seen Langsmith before?
Yeah.
Yeah? Okay. And reusability, so chains can be reused, combined, and tested independently. So yeah, also interesting fact, I want to continue this line from the previous presentation. So actually, that's the whole stack of Dia AI. It's a helpful assistant from Dia developers. And actually, they use the same stack as we have in this course. So Python, FastAPI, and LangChain. And we already know what is Python and FastAPI. And today we will speak more about LangChain. So yeah, that's, I think, a sign that this stack is relevant. So LangChain. Well, we know that's something about language, right? But also it's something about chain. So everything in LangChain actually consists of runnables and chains. So what is runnable? Everything in Python, everything in LangChain is runnable. It's something you can run, but actually don't confuse it with callables, because callables is a little bit different thing. It's something you can call. Runnable is something you can run in terms of LangChain. I would like you to think about runnable as an element of the puzzle. And chain is this line of puzzle that are already combined together. And in runnable, you also have this input and you always have an output. So you need to provide some data and you will receive some data from runnable. And like just in puzzles, you have these different forms and shapes. And if those forms or shapes are fitting, you can create a chain from it. Yeah, so let's actually do some. So can I draw here or here? Okay. So, actually, yeah, my handwriting and hand drawing are like really bad. So I'm sorry in advance. So yeah, let's make it more smaller. So it's runnable. It has some input and maybe like even several inputs, and it has some output. Yeah, that's a simple runnable. And all the runnables and all chains you actually can and you need to invoke. Invoke is a method that allows you to pass some data inside your runnable, to pass some initial data to start your runnable and to receive your information. So, and then you can add another runnable here. And output of this runnable will be the input of this runnable. And you can add another one. Okay, yeah, so obviously, okay, it will look like this. And now the output of this runnable is the input of this runnable, and in the end, you will have some output. And everything here is called actually a chain. And also, you can invoke the whole chain. Actually, chain itself is a runnable. So it also has an input and the output. And input of the chain will be the input of the first runnable of the chain. And output of the whole chain will be the output of the last runnable in the chain. And you have this chain, and you need somehow to start to make it works, and you still have this invoke method that starts. It's like firing the throttle, or like starting this chain reaction, actually, just like in physics, when you need to have this small particle to start this chain reaction. So you just need to like invoke and everything will work, and you will have the response. So, okay. Let's just think what runnables can we have. So when we speak about LLMs, so what should we start from? We have some question, we have some issue, we have some request to our model. In other words, in terms of LLMs, how we actually call it, like some request. It's a prompt. But actually, we don't have a complete prompt. We have some prompt template because sometimes, for example, we need to add a question, we need to add some specifications, some user information. So we don't have a complete prompt, we have a prompt template. Prompt template, okay. Prompt template. So we will receive some parameters, and in the end, we will have complete prompt in the end of this thing. Prompt value, I think it's called, or string actually, or string. So what else we need? When we have already a prompt, we need something to work with this prompt, right? So we actually need a model itself. We need a model. And when model receive this prompt, in the end, it will actually give you a response. And in most of the cases, it will be, in terms of LangChain, it will be AI message. But actually, this AI message doesn't contain only string, only response. Also, it has some additional metadata. It has, for example, some token usage parameters, and sometimes you just don't need all those parameters. Sometimes you just need an output, raw string of the model. So actually, there is such thing in LangChain as parser, and the most famous is called string parser. So if you think about AI message as, for example, a dictionary where we have a content with some value and some different other keys and values, then string parser output, I think, string output parser, then string output parser will do the following. It will just, from this dictionary, take only this value from content key and will return this value. So, that's actually the whole diagram of a chain. So, for example, here we can add some, I don't know, username and question, question, or like topic. We can insert it in our prompt, then in our prompt template. Actually, in our prompt template, it will add everything from here into our prompt. We will receive prompt value in the result. Then our model will receive a prompt, provide us like this object of response of AI message, and then our string output parser will take actually string from this object and return it. And everything is started with invoke, where actually we pass those values. Yeah, diagram looks like this. I told you that my hand drawing is very bad and handwriting bad as well. But how we can do that in code? We have these different prompt, model, and parser. We need somehow to unite it. We somehow need to tell that the output of one runnable is the input of the next one, and output of this runnable is the input also of the next one. And in LangChain, we have very cool syntax sugar. We have this pipe notation. So we just need to do like this, need to add this symbol. And it means that, yeah, output of the prompt will be the input of the model, and output of the model will be the input of string parser. Yeah, and that's it. And we just call invoke, and everything works. That's just how it works. Cool. So let's actually continue. Is it good? Okay. Okay. Cool. So that's how you actually install LangChain. You need OpenAI. You need LangChain, OpenAI, and Langsmith. I'll tell you later about Langsmith. And actually, that's how you add everything that you need to, in terms of your environment. And also, I want to remind you that that's a bad way. That's not how you want to do that in real projects. Oh, live coding time. Hooray. I love live coding, actually. So let's actually start. I have some template here. So for example, let's just also make a simple route that will return us jokes as well. So yeah, let's start from prompt template. Okay, I have my my Copilot. Okay, that's just another sign that I really like to use those helpful assistants that use AI.
Do you need to create a project, or we can do it in previous point?
I think you can do that in previous. I think like the whole idea that you will expand your previous project to add and add some AI functionality. Okay. Yeah. So you're a helpful assistant, and you tell jokes about topic. But that's just a string. We don't need string. What we need is actually prompt template. And from template, and it will allow us actually to input and then replace this topic value, this topic variable. It's like it works in a similar way how you work with your own HTML template. So you will be able later when you invoke, you will be able to replace this topic with your value. Actually, prompt template is runnable itself, so let's just try to invoke it. It can be invoked. And let's pass here a topic. And let's see what we have here.
Oh.
Okay, let's save it. Let's save it. Let's go to our documentation. here we have our new route. We have some topic. Okay, so what joke do you want? About what topic?
Those burn and it's started when it's year looking.
Okay. Okay. An energetic.
Energy, probably just energy.
Yeah. Energy sphere, right?
In this way, I don't know.
Okay. Okay. We don't add so we just have a prompt here. So yeah, that's how our result of our invocation will looks like. String prompt value, and text of this value is your helpful assistant. Tell me a joke about energy sphere. So energy industry, I think. Okay, it doesn't matter. So yeah, you see that this value is replaced, and now we have complete prompt value. So we have already an input from for our model. So let's actually create a model. Model will be chat OpenAI, and our model for O mini temperature, let's let it be 0.7. It also has some warning, but I'm pretty sure that's the correct way. And let's actually create the simplest chain that we can create. So the simplest chain will be model and prompt. Okay, that's not correct. My my copilot suggests me the wrong thing. That will be the correct order. So yeah, that's the pipe notation that I told you before. That's how you can tell that the input, that this string prompt value that you have from the previous invocation should be the output of this chat OpenAI model. And yeah, let's just invoke our chain and see what we have now. And actually, let's let's just let it be. Save it. Let's make another request. It's loading with bit. Okay. And now, as you can see, as I told you, it's like AI message, and it has like a lot of different parameters. And like the most of these parameters is not really necessary for you. I think what you want is a content. And okay, so let's read the joke. First things first. Why did the energy sphere break up with the light bulb? Because it couldn't handle the constant switching. I didn't get it. Okay. Can someone explain it to me? Okay, I think it
Starting common.
yeah, and it
Part in books.
yeah, the industry maybe
In Ukraine.
in Ukraine. I don't think that this model has the relevant information, but okay. Why did the Ukrainian energy company bring a ladder to work? Because they heard the power lines were going up. Okay. Let's just continue. Let's ignore it. Just, it actually doesn't matter. So yeah, that's the simplest chain you can create, just with template and model. But as I told you, you can create string output parser, and call it. And yeah, and then just we can return the result actually. Save it and go to our okay. And as you can see, we already have, okay, I think I need to, yeah. as you can see, we already have our only content in response. Why did the renewable energy engineer break up with the fossil? Okay, let's continue. So yeah, we already have just a string, and that's actually what we need here. Cool, let's go back. Let's actually go back to our presentation. Yeah, there are a lot of different runnables in LangChain. There are really a lot of them, and I don't really think that all of us in all our life, in all our career, will use like even 25% of all the runnables LangChain can provide, because there are runnables for really different tools and for really different aims. Okay, so okay, let's actually go back to code, and I want to ask you if everything is clear here, if everything is understandable here.
What?
The import. Yeah, that's how it works. So from LangChain core, we import output parser. From LangChain core prompts, we import prompt template. And from LangChain OpenAI, we import OpenAI model. Actually, you don't, that's also important here for LangChain as well. So it will automatically add this key to your LangChain chat OpenAI model. But that's, for example, isn't important for LangChain. But let's just not break this request. So yeah, but like in general, in the whole, do you understand like the whole concept of LangChain of everything is just a chain actually? Okay. So let's actually continue with presentation, and I think I have a break slide, but I think it's actually not the time for the break. I think we can continue and start a break a little bit later. So let's make it more advanced now. It was LangChain in like a ground level. It was just to show the whole idea, the whole concept. Now we'll make it more advanced. It was the joke that after the break you will be like, oh, and I will like, now it will be more advanced. But yeah, but we will make a break a little bit later, for sure. So structured output. Yeah, I told you later that sometimes, in most of the time, a string is all you need, but it's actually not true. String, in most of the times, you need more information than just a raw output, raw string. You need your information to be structured, and if you will just ask ChatGPT to provide some structured information, there is no guarantee that ChatGPT will do that. So it will return you a string. Maybe it will be JSON. Maybe it will be a correct JSON. But yeah, it's sometimes ChatGPT can be really chaotic and just return you some nonsense, or not follow some rules that you told him before. So yeah, but do you remember from my previous lecture when we talked about Fast API, we also talked about some structure. We talked about some tool that helps us to follow some structure, to actually add some restrictions, add some boundaries, to make and to protect us from some unstructured garbage that can be sent to our API. Do you remember? Yeah, Pydantic schemas. That's correct. And also, LangChain also work with Pydantic, and Pydantic is widely used to make the output of LangChain more structured. So, yeah, let's actually just take a look on this joke schema. So, in this schema, it's just Pydantic model that are extended from base model Pydantic. We have some comments here, and we have, for each field, we have a description. And actually, here, this description is even more important than in FastAPI, because in FastAPI, it was just for documentation purposes. I can find the Stirachka. Okay. Okay, thank you. Okay, okay. Yeah, but here in LangChain, this description is actually very important, because that's like an additional prompt for your model. So it's just an additional information for your model that will tell you that, okay, setup is just a field to set up a joke. Punchline is obviously a punchline of the joke, but for example, for a rating, it's very important because it gives for the model more context what you want to receive in this field in the result. So it will be an integer from 1 to 10. Actually, you can add like more of these Pydantic parameters like max length, greater equal, lesser equal, and so on. And a model will also understand that and will follow these boundaries. So yeah, that's like the whole Pydantic class, Pydantic schema. We have a model, and that's how you can connect your model to your schema. We using with structured output method, and passing here actually type of your created Pydantic schema. And when you will invoke a joke, invoke a request, it will return you a structured joke, and you will be able to use it not like a dictionary, but like a Pydantic model. So actually, let's try it. We have plenty of time. Yeah, let's try it. Let's create this class joke space. Probably that's because I have my Copilot turned on, so coding is faster than I expected. Base model. So let's actually do that. Setup string with some fields, Pydantic, but also small note. Pydantic has base model, and also LangChain has this base model, and I think OpenAI have the same base model class. So be very attentive what you actually import. So because sometimes you can import base model from a different library and it will not work. So yeah, let's add some description, because as I said, it's very important. Okay, punchline and some rating, integer. And as I said, we can add some, for example, greater equal 1, lesser equal 10, and let's just remove that. And we'll take a look whether model will understand the range. Yeah, that's all we need. That's all we need. Then we can add that to our model. Let's just create structured model. We will use the same model, but with structured output and with joke type. Then here, we just don't need to use structure output parser because we don't have AI message, and we obviously don't have content of AI message. So we just can remove that. We just can't remove that. Yeah, we just can leave that as it is. Let's save it. And okay. We need to include that structured model in our chain. And now we can save that. And now we can move to our documentation to use that. Okay, let's select some different topic. Okay, joke about what? Okay, apples. Just apple. Okay, there's no context. Let's execute that. Okay, rating 5. So it's a middle joke. Why did the apple stop in the middle of the road? Because it ran out of juice. Okay. So now you can see that output is structured, but also you can, for example, so now you can see that in the result we have this joke model and not some like random dictionary. So now it's structured. And you can use it to obviously rating, and it will work. So yeah, that's about structured output. And I think now we actually can make a break. Okay?
And
Cool. Thank you. So we will continue in... Okay, guys, let's continue with our presentation. And yeah, already talked about structured output, so let's move forward. And now we have chat history, templates, and messages. So as you could see, sometimes prompt doesn't consist only with one single message, with one single instruction, but it can have like several messages from system, or actually some instructions for model, like from human message that are messages from a human that are requests from human, it's your prompts, and AI message that is answer of model. And actually in ChatGPT there is a way of how also to add these different types of messages, and it can be actually very useful because I think a great feature of ChatGPT is that it remembers the whole context of your conversation. So for example, it provides you some response, it asks you some question, and you like respond yeah, yes, or no, or provide some additional information without direct question or direct response. And ChatGPT will understand that because it has a context of the previous messages and will answer correctly. So yeah, how to do it? Let's take a look on this second example. So here we have message placeholder. And what is this message placeholder? It's a placeholder for the messages that you can insert later in your chain. And in this placeholder, we can paste all the messages that was before our current request, our current question. And it will give the model the whole context of the previous conversation and opportunity to answer the question correctly. So let's actually do some more coding. And let's So enough jokes. I think let's do some really useful stuff with the systems. So let's start. Let's actually create a new prompt template. But instead of prompt template, we will have chat. Oh, sorry, I forgot. Chat prompt template. Okay. The cell was chat prompt template. Messages out here. You can paste it like this. Use conversation history to answer the question. Actually, we can even remove that. You're just a helpful assistant. And here we can add this message placeholder and add some variable name. Variable name will be like chat history. Okay. But actually, that's the one way to add these messages, but we also can add it in a more different way, like human message prompt template, and from template, and like this. And it will be like exactly the same. We can do the same with the system. So system message prompt template from template. I like this format more because it's not some like also default data structure. It's just a class, and for me it's more obvious how to work with a class. So yeah, we have a system message prompt template, we have message placeholder for different messages, and we have human message prompt template that actually is our question. But now we want to fetch chat history. We need to fetch a chat history. But before that, let's add also model. It will be the same model. And as about output, I think we can use string out parser. So let's create chain from template, model, and string output parser. And what we need here for now is a question. Can invoke paste question. Question. We don't have it. Let's actually try to run it. Save it. Let's go to our documentation. Let's reload it. Whereas we now have this new endpoint. We can add some random chat ID for now, and a question, fact about space. Let's execute, and we have a server error. And that's because we don't provide chat history, and it's required here. So yeah, ChatGPT chat prompt template is actually expecting question and chat history, and we only provide question. Okay, but we also have some different issue here. Expected question received, facts about space. Okay. Yeah, like this. Let's execute. Yeah, we have same thing, I think. But yeah, let's just continue. Maybe we just need to remove that. No. Okay. Save it. And yeah, let's actually fix that. Let's just comment it for now, and we will see if it will work without this prompt template. Let's execute. Yeah, it has no problems now, but we forgot to get and print result. Let's print this result. And let's actually return the result. Save it. Let's go to our documentation. Let's execute one more time, and at last receive facts about space. Cool, then it works. So now let's create some, let's actually receive chat history. So I already have this database mockery. Let me just make it a little bit more visible. So yeah, I have this chats database that already have for different IDs, different messages. And for example, this third chat have answer with a question. So then we will be able to answer this question, and a model should understand us and provide correct answer again. So yeah, the question is, can you tell me a fun fact about space? Sure. Did you know that a day in Venus is longer than a year? Question mark. So yeah, let's just import that. Let's for now just chats database. Get chat ID else empty list. Chats equals, or not chats, messages. Let's insert it as using our invoke method. And in this way, we will insert our messages from our database here. So instead of system message, so instead of like this placeholder, we will have different messages from human and from AI. Let's save it. And let's actually try if model understands us. So what was the question? What was the question here? Did you know? Okay, then we can respond like, no. Give me more details. So without any third ID. So yeah, without any additional context, model will not understand that I ask about Venus, I ask about space. So only because we add some additional messages, additional message history, it will be possible. So let's actually execute. Yeah, and it works. It continue responding about Venus and about space. So yeah, it says absolutely. And another thing about space and solar system. So yeah, that's how you inject the chat context in your Planet chain. But actually, that's not the best way how to inject data in your chain, because yeah, you have your chain, it's here, and your this method, this functionality is like out of chain, and it's not very good because you usually want all the functionality to be inside your chain. So then it will be traceable using blacksmiths that I will show you later, and it will be very easy for you to find what's going wrong, maybe what information you get, how it works, and so on. So that's actually not the best way, but we will fix that a little bit later in a moment. So yeah, let's continue to our presentation. Inserting external context. That's actually how we will insert any other data. Let's find new runnables. There are 3 new runnables here in this example. Can you find all of them? Find all of them. Is it visible even? Okay. So yeah, only 3 of them. That's it? Yeah. And the third one is...
Backend.
Yeah, that's correct. We have 3 new runnables. That's only 3 from like 1,000. But they are the most popular, actually. One of the most popular ones of the... Okay. Yeah, the most popular. So, actually, what those runnables do? So, runnable lambda is obviously wraps Python function as a runnable. So then you can use any function as a runnable inside your chain. And yeah, it's useful when you want to insert some context in your runnable, or for example, if you want to include some function in your chain. Yeah, that's the way to do it. You just paste lambda function or just the name of your function, and it will work. It will work. Runnable parallel obviously runs different runnables in parallel. So if you don't want to wait for some function finish and then wait another one, you can run it in parallel and save response, save result in different fields. For example, like context and question. And runnable pass-through is actually returns whatever it receives. So it receives something. So here you can see that we don't receive a map, we just receive a string. So it's just a string. And when we are here, runnable see, okay, I receive a string, then I will just return a string. I will just write the string in this question. So then in our context prompt, which is not visible in this screenshot, it will be it will be able to add this question to this prompt. So yeah, let's actually try to add some context. Let's do some more coding here. Let's first things first, let's just rewrite this part. So instead of starting from prompt template, let's just add some runnable parallel. Okay, add this one. So here I don't need to pass all the context from all the messages from chat history. I just want to pass only chat ID and pass only chat ID. And now I need to calculate what messages I want to paste in my chain. So let's remove that. Let's actually create a function. Get get chat history. It suggests to do that in that way, but as you can remember, your runnable will receive not just a chat ID, it will receive all the context, all the input from invoke, because it's like a first part. So here we'll have some data and we'll have a dictionary. And now in this dictionary, from this dictionary we will get chat ID by key. And then we will be able, by this chat ID, receive our chat history and return it. Yeah. So runnable parallel. And here we can add chat history. History and add a runnable lambda with the name of this function. But now we need somehow to pass our question, because runnable parallel receive question, but it will return only chat history. We need somehow to say that, okay, we need to pass our question to the next step because it's important. So we also need to add question. But we cannot just use pass-through here because pass-through will again return the same dictionary, and we don't need the whole dictionary. We don't need chat ID anymore. We need only question. So we need another runnable lambda. Yeah, that will take like the whole dictionary and take from it only question and return. Yes. And yeah, that's how it works. We can again save it and execute it. Yeah, and it also provides another fact about space. Cool. That's how we. That's the better way how to insert some context in your chain. So let's actually try to add even more context, because in my database file I don't only have like chats database. I also have facts database. So let's also import our facts database, and let's force our model to respond only using these facts. So if there are no useful information in this database, it will just respond with something like, okay, I don't know, I don't have such information, which is also can be useful. So we can do that actually as well by creating actually another function. So let's define get facts, also data dictionary, but it will be like a little bit more complicated. Okay, it's also like generated, but yeah, let's just write it. Question. Okay, that's actually what I need. Okay, maybe I just, not actually what I need, because let's just return facts, and if nothing was found, no relevant facts found. So what this code actually does, it takes a question, makes it lowercase, then it will just search all our database, and like if some of these values are inside our question, then we can use this fact to generate a response. Very dumb and very simple logic, but it's just to show how it can be. So how we can actually, first things first, let's just improve our prompt. So it suggests me use the following facts to answer the question. Facts. But let's add another. Okay. If the facts are not relevant, answer that relevant, right?
Yeah,
Relevant. Okay, same. Answer I don't know. And yeah, okay. Save it. So yeah, now we need to provide a fact that can be used. So actually, for that, we can add another lambda with the function that we created before. So it will take all the dictionary, find the fact or no relevant facts found, and yeah, it will insert it inside this variable and it can be used in this place. So yeah, let's save it. And now let's ask some question, but I just need to check what I have in my database. I have something about honey. I have something about Python, elephants, ocean space, and bananas. Okay, so tell me something about Python. Let's execute. Python is named after the British comedy series Monty Python Flying Circus. And let's take a look in our facts database. That's exactly the same string. So it works. So it injects this fact in your prompt, injects more context for your prompt, and then it only answers using this context. But let's try to ask something different. Let's tell me something about, I don't know, apples. But I like apples. I don't know. So we have this restriction now. So if no context is available, then model will just respond with I don't know. And that's fine. So everything actually works. Is everything clear at this point? Do you understand how this runnable parallel and runnable lambdas work? Runnable lambda. Okay, so why we have runnable lambda here? Because at this point, when we have this runnable parallel, inside of this runnable parallel, we have this dictionary. We have this whole dictionary. And now we need to transform this dictionary to another one, where we have chat history, question, and fact. But here we only have question and chat ID. So here we transform our chat ID to chat history. Here we just receive fact from a question. But we still need to have our question in our prompt. So we go to this dictionary. So this data actually is this dictionary. So we need to, from this dictionary, receive our question and pass it again to the new dictionary, so it will be available later in our prompt. So that's why we have to again call this runnable. Yeah, so that's actually kind of complete example of how you create more context using messages and some external, maybe mocked, but external data sources. But yeah, LangChain still have a lot of different tools, a lot of different runnables to work with vector databases, with NoSQL databases, with relational databases. So yeah, it has a lot of things under the box, from the box, but you can write it by yourself and inject different context. Let's go back to our presentation. Okay, so also, you probably see when you use ChatGPT or any different models that it responds with, not with the single message, but part by part, token by token. And maybe you have this question how to do that. And in LangChain, you are able to stream your output. So yeah, when you ask a question, you just provide this input in the same way as you provided for invoke, but it's just a different method, it's just a stream method. And in the result, you will be able to iterate through result of this stream output and, for example, print it. But how to deliver these results to the client is actually another good question, because for now you only learned that client has to initiate this request response cycle. Only client can go to server and ask for data, but we just cannot use it in this case. For this case, we need to create some two-way communication where server also can go to client and provide some data for client. That's possible, actually. That's maybe you heard about sockets, WebSockets, and so on. It will not be covered in this course, but such thing exists, and you can use it in the future. So that's how you do streaming. The very cool thing about LangChain is Langsmith. Actually, Langsmith is a platform that opens for you a lot of different opportunities, like observability, tracing, debugging, prompt engineering, version control system of prompts, evaluation, different testing, human feedback, measuring performance, different UI to show some graphics, some different metrics like token usage, money usage, success rate, and so on. And I already connected Langsmith to our project. Oh, I didn't. Now I connected Langsmith to our project, but I think I need to kill this process and start a new one in order to work. Let's just make another request. I don't know. Okay. And let's take a look in Langsmith. That's actually, okay, I need to make it more visible now. That's actually how Langsmith looks like. So at home, we have these different projects. That's the name of the project I created and I connected. So let's take a look. Here, for the last 7 days, I have several requests. But for the last, I think, hour, I have only one request that I just did. It takes like 0.78 seconds. It has an input, it has an output, and it has a lot of more different details. So, first things first, it has these get chat history and get facts functions. So that's why I told that it's important to have these functions inside your chain, because now they are visible inside Langsmith, and now you can just take a look. So what you have here and what you have in result. So as an input, you have this question and chat ID, and as an output, you have this human message and AI, and the same thing for facts. So in this case, there's no relevant information is found. And let's take a look on ChatGPT OpenAI. So here we can see that what was the request. It has our system prompt, it has our message history, previous messages, and now in the end, we have our new request about Apple, and in the end, we have our output. And that's the way how you can look and how you can trace your requests, because this chain can be really more difficult. It can have more and more steps, more and more runnables. So it's very useful when you can see how your chain is working. It takes really not that much tokens, not that many tokens. Also, what we have in Langsmith is, for example, monitoring. We have different charts here. So yeah, in some, I have 5 requests, 5 success requests, but sometimes there can be some errors, and they will be also displayed here. Also have some tokens usage, or it's like trace latency. Okay, tokens usage. Okay, it's LLM calls, LLM latency. Okay, here we have some costs that are really low costs, which is good actually. And some more statistics about tokens usage. Also, it has a lot of more functionality like prompt management. We can write prompts here and save prompts here, and then you can fetch those prompts directly from Langsmith in your Fast API application and use them directly from Langsmith. So that's the place where you can store your prompts as well and run some experiments. So